Hello, this is Dr. R. Jefferson George, and looks like we're recording. So um, let's do the SPSS portion of our correlation video. This is Edle 6110, and we're in the summer semester 2018, and this is for week 5. So as you can see on my desktop, I've opened up IBM SPSS, and I'm going to go ahead and open the advanced theory data set. So all of you should have that. And so just click on that and say open, and it should open. It asks us what we want, what sheet we want to use. We're going to open in sheet 1 because that gives us the data set. And if you look at the data set, there are our 100 students and the different variables: gender, ethnicity, free and reduced lunch. And then our content areas: math, language, science, and writing, the grade level of the student, and their GPA. And so this is our data set that we're going to be playing with today. And so we're going to do our analysis for correlations. And we're going to scroll down just so that we can see we have 100 participants, 100 students. And we'll start off initially by moving that over. So we'll start off initially by just analyzing, just looking at our data set. Let's first go to variable view and make sure it's set up the way we want it. And so it looks like that in this data set, the student variable is set to scale, and so it should be nominal, so we'll change that. And then all of our nominal variables, they don't need to have decimals, but our scale variables do, and so we'll go and change these scale variables to give them 2 decimal places. And grade is nominal, and then GPA though is a scale. And so now that we've corrected that, if we look at everything else, numeric, width, decimals, values missing, our measures are all correct, and our input. So we can go back to the data view, and you can see then that you have the 2 decimal places with each of our variables. And so that'll help us when we do our calculations. So the first thing we want to do is we'll go to Analyze, and you should probably always run a descriptive statistics before you do any analysis. And so click on Descriptive, and we'll just look at the descriptives of our content area variables and our GPA, since that's what we're going to mostly be looking at. And so look at options, and in descriptives, we want variance. We can look at range and say continue and say OK. And so it gives us our descriptive statistics for those variables. And the other thing that you can do, because we want to know what, even though it does give us the range, the minimum and the maximum here, it doesn't, here's the range, 42. If you'll notice, it doesn't give us the mode. I remember you guys asking about that in the discussion. So let's go to descriptives again. This time run frequencies. And we're still just going to run the content area variables and writing and GPA. And let's look at statistics. And we'll do the mean, the median, the mode, and we'll do standard deviation and variance and range. We'll go ahead and do minimum and maximum, and that's what we want to look at. And so that will give us these values for our content area variables. I don't know if there's really nothing to gain by having a chart, but we can look at a bar chart. Or this time let's look at a histogram, because it's always fun. And so we'll do that, and nothing to change in our formatting. Style, we don't use Bootstrap, and so we can say OK. And again, it will give us our descriptive variables. Here's our statistics for frequencies, and look, it gave us our frequencies for each of the variables in the whole data set. So that way you have this information if you want to look at it. So here's your minimum and maximum. In math, 221 to 263 were the scores. In language, 221 to 259. In science, 220 to 276. And in writing, that's where some of our lower scores were, 175 to 234. And GPAs run between 2.5 and 3.4. And so then it gave you a histogram of each one of these frequencies. So take a look at that. And, you know, the data is, by looking at the histogram, it's easy to see. The data is more or less normal. Language scores, however, are skewed to the upper end of the scale, and math has more, it's a more normal distribution. So language is the only one that's skewed higher than all the rest. But then you have these outliers down here that are very low in language. So we can look at those, and that's one of the benefits of having a histogram, is that you can take a look at where all the scores are grouping, and you can be able to see how they're coming together. So taking a look at all of that, we can go back. I just moved it to the top, but it's not going to matter. We're going to take a look at, come down to correlate. And we're going to look at bivariate correlations. And again, going to look at everything together. And we'll look at just the content area. So math, language, science, writing, and GPA. And remember, we're looking at the entire data set. We're going to do a Pearson correlation and a two-tailed, which means it goes to both sides of the normal curve. And there's really nothing else we want to include, so we'll just leave that like it is and click OK. And here it gives us our correlation table. And in the correlation table, you can see that math is highly correlated with math, and so there's a 1. Language and language, science and science. So that's the ones that go down the middle of the table. If you were to look at the correlation table, either the upper triangle or the lower triangle, you would find that those are the same. Math correlates with language at 0.289, and language correlates with math at 0.289. So you can see you get the two variables correlating the same in both sides of the table. So oftentimes you'll see a correlation table where the upper triangle is removed and then the APA format, and so you'll just get the lower triangle where the starting with the 1s and then going down. So if I we would basically just erase all of this part and then keep all of this part in here, and so you would still see the same correlations and you would still have the same data. Also, when we're looking, since we're looking at this, you can see there are 2 asterisks here. 0.289 is significant, and so it tells us here correlation is significant at the 0.01 level, which is 99%. That this is not occurring by this is not occurring by chance. That there is some sort of a correlation going on. See, there's another correlation here with science and language, and here's another one, science and writing has a correlation. So you can see overall in this data set of 100 students, which is all 4 grade levels and all 100 students in the high school. So these are the 3 areas that have some level of significance, statistically significant variables. And so but we always are concerned that the 9th grade test and the 10th grade test and the 11th grade test, or all of them, are a little bit different. And so one of the things we can do is, just like we did in previously, we can go over and split our data set. So in this case, let's split our file to see if there's some, split it by grade. And we're going to organize output by groups, put our grade there. We'll sort the files by grouping variables, and we'll say OK. So now let's just, if we just want to, we can just run the exact same correlation, come down here and do the exact same bivariate correlation. Math, language, science, writing, and GPA. And we're not changing anything except that now we've split our file by what? By GPA. So by grade. So here's grade. And you'll see all of the variables. Here's our 9th graders. And here's our 10th graders. Here's the correlation table for our 9th grade, our 10th grade, the 11th grade, and the 12th grade. And so you remember that what the correlations look like in the different grades. When we grouped the whole group together, we only got significant relationships in 3 areas. When you start looking at the grade levels in grade 12, looks like we're only getting a relationship between math and language, which we had before, but this time the correlation is much higher. It's 0.704, so you get a much higher correlation. There's no correlation in the 11th grade in between math and language, so that should tell you something about the test takers as well as the test. And grade 10, and look at, there's only a 0.081 and not statistically significant. And then in 9th grade also 0.204. So what that tells you is that, well, it's the 12th grade test that's giving you all of the correlation between the math and the language test. And there's not a lot of correlation in the other grade levels. And so you start looking at this and you go, well, there's maybe the what's happening with, because it just makes you ask more questions. What's happening with the math and the language test? What's happening in the 9th, 10th, and 11th grade with the math and language test? Why, if there's such a high correlation in the 12th grade, why isn't there any correlation at all in the 9th, 10th, and 11th grade? So we can also look over here. There's a correlation in the 9th grade between language and science. Let's look over here. There's not any correlation at all, hardly at all, in with 0.004 between language and science in the 10th grade. There's a negative correlation between language and science in the 11th grade. And when we get back to 12th grade, there's the bivariate, the correlation coefficient is 0.304, but it's not statistically significant in between language and science. So in fact, the only thing that is statistically significant in the 12th grade is the correlation between the math and the language test. So this is an interesting data set, and there's a lot of to create an analysis here. We can go back and change our data set this time. Again, split the file, and we're looking at grade. Let's also look at gender and split each one by gender. So let's say OK. Let's run the same correlation again. Use the same variables. Say OK, and see what it gives us. It gives us it did split it by gender. So now we know if the males, remember males are 1 and females are 2. So is there any correlation if we split the file by gender and if the 2 genders are learning in a different way? And so you can look at the correlations between the math and the language test. Males, 0.445. Math and language test. Females is a minus 0.267. So it's telling us that there is some relationship, but not statistically significant relationship between the 2 tests for the males, but it's going the opposite direction for the females. And so the language and the math scores are going in opposite directions for the females. So again, looking down through the correlations in each grade level just gives you information about the test and then about the test takers. So in the 11th grade, males between language and science has a negative 0.75 correlation, and it is statistically significant. And in the 12th grade, but no significance for the females. And then in the 12th grade, I'm not seeing any statistically significant correlations for the males, but for the females, between math and language tests, there's a 0.94. So your females are doing much better in the 12th grade, and they're the ones who are driving your correlations. And so they're the ones that are helping create that relationship between the two tests. And so as you begin to look at the data that you're getting, then you can also get your instruction. And so begin to modify your instruction to include both genders, or find out why the females are more receptive to the instruction, why the learning is happening with the females at a greater rate than it's happening with the males, and why there's not a statistical significance between the tests for one gender, but there is for the other. And so you can start looking at all these different variables and these different situations. Going back, taking our split files again, we can by grade. If we want to remove gender, then we can also look at ethnicity and see if there's something we want to do with ethnicity. So let's say OK and go to analysis and go back to correlation, do a bivariate correlation. And this time, since we've split the files by ethnicity, we haven't changed anything. We'll just do our correlation, and we'll see what happens with, here's our ethnicity in the 9th grade. So if I remember correctly, number 1 was for our white students, 2 was for the black students, and 3 were for the Hispanic students. So you can see where there's a significant relationship between the test for math, for the white students, math and language, language and science, math and language, language and science, and I don't see another one. So we have those, and then we have a very high relationship look for the females, math and language for the females, and come down here. So ethnicity 3, our Hispanic, I mean our looking back over here, this is for ethnicity 2, we're looking at for our African American students. Here, math and language is highly significant, and then ethnicity, grade 10, grade 2, grade 3, and very little to go on in grade 10 for the Hispanic population. I would say there's some errors in the way the data is reported, but we have to look and see why that came out that way. Here's the reason right here. There are only 3 students, so that's why. And so there's such a low number of students. There's nothing. They're not able to get a valid response. And so back and look. At each grade level and so on. So this is how you do this. And I would come back to my data here, change my split file. If I wanted to look at the, not by grade, but if I just wanted to look at the overall ethnicity, I would just change it back to ethnicity and remove grade so that we're not disaggregating them by grade, run it again, and then compare it with the original analysis that we did for the whole group, and then this will be for the whole group. Do a bivariate correlation there, say OK, and let's look at our table again to see if there is some significance as a group, so we can avoid the Hispanic population where there's only 3 in one grade level. And so if we see a stronger correlation, we don't, but it does give us more valid data. There is a correlation between GPA and the writing test. And so it's a negative correlation. And so perhaps there's an ESL population that we need to be looking at. And so you can get some data looking at that. In the African American population, we're not seeing a statistically significant area of concern there. And so then we're in the white population, we're seeing a statistically significant correlation between the math test and the language test. And if you remember when we split the file, that's coming from the females. It's coming from all of our girls in various grades, but the 12th grade was the one with the highest correlation. So there's a lot of things that can be said for that. This is how you do the correlations in SPSS. You should be able to complete the assignment without any trouble. When you're done, we'll remove the split files so that you're not confusing your data, and say OK, so that clears all of that. Then the next thing that you do then is just complete the assignment. I was going to show you, I'll go back to the very first one we did, that how to take the correlation file. Here's our very first correlation file, whole group, and one, just click on it, copy, say copy special, seems to work best, and then open your Word document. And once you open the Word document, if you'll just copy it in there. And so this gives you all of your variables, gives you your correlation table. And so you can click on that. We can change we want to remove space. Just make sure that your Word your word justification is correct. Making sure that your indentions are 0, that there's no hanging indent, and no spacing before or after. Line spacing should be single, and then click OK. So that should firm up your table pretty quickly. Now, if you wanted to, you can do all the table options. You can go in and remove. Go to borders and shading. Could be able to take no borders out. So if you take all the borders out, you can come back and so you can clean this up. You can take out move this out of the way. You can take out where it says significant two-tailed. You can take out the number of students, and you can create a much more compact table. You can put a line at the top and a line at the bottom and turn it into APA format. And you still have your levels of significance for your correlations. So line at the top, line at the bottom. No, let's do this line down here. And then line at the top again. So then that way you can come back in and clean this up if you want. And remove all this extra information. So that gives you the information you need. Math is highly correlated with math, and then gives you your correlation table with your bivariate, with your correlation coefficients here. So And bivariate simply means there are two variables, so math and language have a correlation. Here's the variable. Bivariate, math and science, math and writing, math and GPA. So we can go back to the SPSS page, look at the variable, look at the data view. Where's our output page? Here it is. Go back to our output, and there we are. So I appreciate you watching. Please use the inbox to email me if you have questions about the assignment, and we can make it as clear as we need to. And I appreciate your time and look forward to seeing what you guys come up with. Have a great day.